All right, it's 6 o'clock, so we're going to get started. Welcome to the second Siligong.js since COVID lockdown. I'm Brad, I'm a developer at Easy Agile. I'll be your MC. First thing, a bit of admin. We're changing this from Siligong.js to Siligong.dev. So it's not just going to be JavaScript, it's going to be anything that has code in it. So it can be a different language like Python, or it can be like just programming an Arduino, just anything. We want to build momentum, we want to make the community bigger. So if we make the talks broader, hopefully more people will come in. We have a new website, Siligong.dev. If you want to present, I'll put a CTA on this later, so you can just go here and put a submission in if you want, or just send an email or Slack me or Jared, and we'll talk. Sound good? Cool. Hold your applause. I haven't done anything. Okay, so we have 3 presenters tonight. First one is going to be Matt Rowles from Devika, who's going to be talking about JavaScript everywhere. Round of applause for Matt.
All right. G'day, everyone. Timely topic based on what we just spoke about, but it still applies. JavaScript's still a great language. So on behalf of Devika, I'd just like to welcome everyone, and it's really a pleasure hosting Siligong.js for the first time. It's good to be in the thick of it in Wollongong now with everyone. So yeah, as the screen says, my topic today is going to be JavaScript everywhere. Oh, thank you. It's going to be JavaScript everywhere and how we use JavaScript through all of the layers in our monorepo product stacks that we build at Devika for our own products and our clients that need them. Just a way of introduction, my name's Matt. I'm a Wollongong native. I've been coding since I was a teenager, but professionally for about 12 to 14 years now. I've been in Sydney for most of it, but it's good to be back down in the Gong, and it's great to see such a good community starting to foster. So without further ado, I'll get stuck into the presentation. So again, what am I going to be talking about? Sorry, that's a bit slow. Using JavaScript and its many forms and implementations throughout our entire stack. So we all know JavaScript as a browser language, and also we can use it in APIs and Node.js, but what we also use it for is to build and deploy our stack and also configure our stack. And we also make good use of it in our data structures and persistent layers. So why do we do this? So we're at Siligong.js. I assume we're all pretty much infatuated with JavaScript, or at least you want to learn a bit more about it. So I won't get into the what just yet. I want to talk about the why we use JavaScript everywhere, because we're pretty philosophical here, and I think it's important to understand why we do this before we talk about the implementation of it. So client success. Devika's client success means that we'll be successful. So clients generally come to us with a business problem or a customer problem rather, and they might not have their own dev team or the means to be digitally sort of savvy. So they come to us for expertise, they come to us for solution. Generally they want to do it, maybe within a certain budget and whatnot. So we want to be the best providers of that service as possible. So client success is the main thing. So we want to use JavaScript everywhere to reduce risk, reduce costs. JavaScript is quick to develop. Like, there's very fault tolerant, has a lot of quirks about it, but we're using it through our entire stack. We get to share a lot of code. This gets us to market quicker. So nothing's of valuable that we build or develop or whatever until it's in front of a customer and we're learning about it. So we want to help our clients get to market, or our own products get to market quicker in front of customers. We also want to focus on the important things. Customer goals, user experience, accessibility, all that kind of jazz. Unit testing for confidence. So having JavaScript all through our layers and in our config means we can do this pretty easily. We can share utility files, we can share data, test data, mock data, all that kind of stuff. And it lets us free up time to focus on these important things. Architecture has changed as well in the last 5 years. Like we've seen the surge of cloud infrastructure. However, even since then, there's been many iterations on that. We've seen serverless come out of the woodwork, and this is where JavaScript really shines compared to other languages, funnily enough, because it's normally not the language that shines. But its weaknesses really become its strengths. And TypeScript. Everyone's here heard of TypeScript, I'm sure. If you haven't, it's just a type-based JavaScript, which is really nice because JavaScript, although its fault tolerance is one of its best things, so you can do things with JavaScript that you shouldn't be allowed to do with other languages, TypeScript plugs those gaps. So we've seen JavaScript turn into one of the most progressive languages in the last number of years, and we're really banking on it. We're really going all in. So again, the philosophy, I'll dive into it a bit more. Like as a team, we want to minimize waste, reduce complexity, build fast, and grow confidence. And we want to promote team-wide best practice at all SDLC layers. This is an important one. We want to maximize component reuse between our clients. So web app, web marketing, we have mobile, React Native, iOS and Android. We want to reuse as much as we can to, again, get to market quicker for our clients and our customers. If it's all in JavaScript, all in the same language, it's a good chance we can reuse it. Heighten security and accessibility to all layers. So you get a lot of this out of the box with cloud infrastructure at the server side. So this is really good. We get to focus on this. We get to do the security headers, all that kind of jazz, and we don't have to like waste time because we're reusing the same code again and again. Same APIs and all that kind of jazz, the same patterns. This is important. I think as developers, it's sort of a thing that we kind of look over a lot. It's the costs of what we do, the implications of it. You know, we build for the customer more and more so these days, but the costs we can reduce. And there should be a thought at the back of your head if you've ever developing something, especially on the server side, because that's where most of the brunt of the costs might come from. It's a good thing to think about. So JavaScript and serverless and the new way of architecture and infrastructure, this gives us this. We can increase scalability and reduce costs, which is like the complete opposite to each other normally. And yeah, like very important, we want to promote a culture of shared ownership. So we build products as a mono repo. So every single layer is maintained by everyone in our team. So we share responsibility for an API if you might consider yourself more of a client-side developer, and vice versa. Everyone's responsible for the success of the product. So, you know, accountability. We want to promote full-stack developers. It's good for the individual. It's good for the team. Increases reliability, all that kind of stuff. And if it's the one language again, it makes this a lot easier. It's less, I guess, scary for people, or like people are less hesitant to jump into layers they might not be savvy on. And the pizza's here. Sorry, I'll be super quick. And we de-risk product launches as well. And this is probably the most important thing, because at the end of the day, if your developers aren't happy and they're not confident, the code and the product and the customers will suffer at the end of that. So this is the most important thing. So that's the philosophy aside. So the language itself, we're all pretty accustomed to JavaScript's quirks. It has a lot of faults, or some faults and flaws compared to other traditional languages. But that's okay. You know, like I was saying with TypeScript, this fixes a lot of those, not all of them, but it does fix some of them. But it makes it a lot nicer of an experience. So the language itself, JavaScript, of course, it's not the most perfect language. However, once we know the ins and outs, once we know these little things, and we can apply certain frameworks and implementations of it that make it a lot safer to develop in production with. This goes without saying. I think the popularity of the JavaScript community is staggering compared to other languages. So if you look here, this is the GitHub state of the Octaverse. So this is the last 6 years, and that pink line at the top is JavaScript maintaining the most code written in the last 6 years on GitHub repositories. Now, again, that's how do you measure that? It might not be that good. It might mean JavaScript developers have to write more code. But I think at the end of the day, that shows that the community is the strongest out of all the languages. And it's backed by this Stack Overflow developer survey, where JavaScript is the top coding language. And if you skip past HTML and CSS and SQL, the next strongest is Python. So, you know, two scripting languages, which is really good to see.
On the left-hand graph, that fourth one down, it doesn't say TypeScript.
It says Python. Sorry, yes, so you're right. I didn't even see this. TypeScript's like 7th or 8th or something. So like them two together, the community is really strong. So this is safe for us as a team to develop in JavaScript everywhere because we can rely on the fact that someone's asked a question before us, or if they haven't, we're going to get an answer quicker to the one that we need to ask. So again, it's about speed and being confident. So the architectural revolution, Node.js has been around for a little while. We've seen Dino, you know, Jared did a talk on Dino last Siligong.js. So these things are happening, but serverless is where this has really taken off, and Node.js has become a really popular language. There's not a serverless talk. I want to talk about JavaScript, but it's hard to avoid. So serverless, if people haven't used it yet, is ephemeral, like functions that exist to do one job at one time and then they disappear. You don't need servers, technically. As a developer, you don't need to know about them. These functions, the code, they deploy somewhere, they get run when they need to run, and they disappear, kind of. So serverless is where we don't care about things to some extent, like memory and threads and all that jazz. Of course, we still care about them. We need to know about them, but it's less important. So infinite scale as well. So serverless lends us to simultaneous running of the functions that I was talking about. So we can have as many of these running at any point in time. So if you have 1,000 customers, there's probably some limit, but most of those customers will get their own kind of run of that function if they all hit it at the same time. There's obviously costs involved, but with Amazon, I know I haven't used Azure or Google Cloud, but I don't know what their costs are, but Amazon is really low. There's free tiers and it's really quite good. So even though it's infinite scale, it's still very, very cheap. You're talking about cents on the dollar. So, and also there's no servers to think about, you know. And why Node.js really shines in a serverless world is because when you're the first customer that's hitting that API through some interface, you might see that the function has to deploy and spin up and run again. So Java and other languages that aren't scripting languages with their own virtual machines will incur this startup time. Even though it's a tiny function, it still has to start up. And whereas JavaScript, Node.js, the startup times are very minimal. So if you do get one of those, what they call a cold start, they're very rare these days, but when you do get one, not only will it rerun, but Node.js is like super quick to spin that up. So yeah, we also do schedule jobs through serverless and queues, like message queues. All of these are attached to serverless, so that lets us write dumb Node.js functions to do one thing and deploy them, and it's easy. And again, what I was just talking about before with the payment, you pay for what you use or nothing at all if you fall inside that free tier. And you have to think about Dockers or containers. Or there's probably some Docker and container people here, but I don't know. I haven't written anything in Docker or containers or Kubernetes or anything for a couple of years now. So, what else? The love sharing. All right, so back to client side for a second. We build React web apps and Next.js static sites and React Native mobile apps. So our clients folder ends up being like a couple of different apps. We also have a core folder within that will chuck all of our state machine, like our store stuff in, and we share it through all of those kind of apps. So we can share, just say you have an API that's called blogs, right? Anything coming back from that will chuck, we only have to write that Redux store once, and then we can shim it in all of our apps. So web app, web marketing app, mobile, iOS, or whatever else we want to do in the future. We only write that once. So showing the love there with state machine. Utilities and config shared throughout the code base. So we use a monorepo again. So if we have a string utility that, I don't know, adds $1 to the front of some value. I don't know. We only write that once. We can use it in our API, use it in our image resize, queue functions. We can, use it wherever we want. We can even use it in our deploy scripts. So it's very useful, and it's all one language again, so it makes it easy. And also means we only have to write tests once, because we've only written it once. So we can share test mock data as well between all of these components. So this comes in handy when you have an API that exposes like a contract of data, like you expect this response to come back, you expect these fields to be in it. We can write a JSON file that we can also consume in the client, and it sort of maintains that contract between that as well. So if you change the API, heaven forbid, if you delete a field or whatever, we'll catch that pretty quickly in the other tests that we have in our client if we haven't called it already in the API. So we only have to do this once and expose it. So this is really handy. And I don't think that's specific to JavaScript. You could do that otherwise, but it's just something we do. All right, so how do we do this? I've probably talked about it a bit tonight, but we have web apps, which is React, web static, which is marketing and blog and stuff, how we serve static content for SEO and whatever, Next.js and React. Again, this is serverless. If you guys want to know how we're doing this, we're sort of in the thick of it now, so come and chat to me, and me and Daniel over there will explain to you. And React Native, and they're all joined by the Redux store. Services, Node.js, we use GraphQL. It doesn't matter really what you expose your APIs as, but it's just really helped us kind of help the client side of development. It's a lot easier with GraphQL, we've found, so we just use it, each to their own. WebSockets through serverless as well. Sending messages and whatnot's all written in Node.js again. Schedule jobs, Node.js serverless, and queues, all Node.js serverless. Infrastructure. Believe it or not, you can actually use TypeScript as a config file to deploy CloudFormation. You can also have CloudFormation scripts that, like AWS scripts that run and deploy stuff to Amazon for you. I haven't used Terraform. I'm sure people here are using Terraform. It looks pretty good. We're pretty heavy on AWS, so we're just going to do CloudFormation directly because it's a bit easier to use. But this helps as well. Like you can reuse data, you can reuse utilities, you can, it's very good. And then persistence. We use NoSQL, DynamoDB. You can probably do this with Mongo and a bunch of other related sort of databases, but yeah, we just store everything as JSON and it's all good. JavaScript everywhere. So what else is there? So we're kind of exploring this at the moment now. Generally data, especially data scientists or data engineers and whatever, they will probably prefer to use Python because it's more supported for mathematical things. However, I wouldn't discount Node.js in this space as well. You can still do at least ETL process, like extract, transform, load data from your data store to like a bigger data store for like your data warehouse or data lake or whatever. I wouldn't discount Node.js for this as well. And desktop apps. This is actually starting to become quite a common theme. People are building desktop apps in things like Electron, I'm sure you've heard of. React Native Web is a thing that Mark, one of our colleagues, discovered as well, that you can reuse the React Native for mobile code traditionally and deploy it to the web, which is kind of weird because it's like React to React Native and then back to React Web, which is, but that also deploys to a desktop app. You can cover all bases with a single repository, which is pretty cool. So we don't have to build any desktop apps yet. We mainly play in the web space and mobile app space, but if you're looking to build a desktop app for whatever reason, like to expand your own clients, feel free. So where's the proof as well? So again, Devika build products for customers. We help them go to market. We help them grow after that. So CleverQ is one of our current projects. We're still working on. It's live. It's been live for about how long now? Like 9 months to a year, maybe? About a year?
14 months.
14 months. Quite a while. So what CleverQ is, it's similar to like a Deliveroo or like an Uber Eats. However, it's within bigger venues, so like RSL clubs and stuff, who tend to have many different like vendors and stuff selling food or other things and beverages, Clever Queue will let you order within the venue and do other things like increase your membership points and all that kind of jazz. It's used daily by dozens of large venues by their patrons, and they're growing quickly. Thousands of transactions a day, probably more than that even. I'm not sure, I haven't looked at the numbers lately. And the infrastructure costs are like $400 a month. And outages, you don't hear about them. We don't hear about them. We do hear about them, and they haven't happened. But yeah, so that's one example. This has been live for a long time, and our clients are super stoked. We continue to help them grow and develop their product, and keep their costs down. And this is all JavaScript as well, just to reiterate. And the second one is probably the better example of how Node.js handles like serverless startup times and all that kind of jazz. Sunny is an extremely popular healthy recipe and lifestyle app. So people jump on, they sign up to a subscription, and they look at like recipes and stuff like that. It's a mobile app, bit of a web app as well, but it's mainly consumed on mobile, iOS and Android. She's super popular. So the person that runs this is a woman called Sarah, and she's amazingly popular. She has a couple of million followers all around the world, which is another thing we have to deal with, like knowing that our infrastructure has to be edge location. So we have to serve US, Australia, blah, blah, blah. So Sarah came to us, we built the app. First day comes out and we get 1 million plus hits. I don't even know how much it was. How many was it? Like 1 point something? It was ridiculous. But 100,000 concurrent users at one point, I think in like within the space of 10 minutes or something, half an hour. And the infrastructure cost, not only did we handle it, but the infrastructure cost was about $3,000 per month. And like that's it. And thereafter, after the big burst and then simmer down, it's $500 a month after that. So using JavaScript everywhere we were able to get these products to market really quickly, like super quickly in less than 3 months. Help them continue to scale, get their trust, help at the end of the day, it's for their customers. Their customers are stoked with the apps, and yeah, they continue to grow and cost nothing. So yeah, so there's the proof. So if you're looking to use JavaScript everywhere, we've done it and we've proved it, and it's all good. Takeouts, don't limit your idea in your head of using JavaScript or TypeScript in browsers or APIs. You can use it in many more places, and start thinking about it. So where to start? Build your next event-driven service. Like if you have like a queue or something you want to do, like send a push notification, for example, on an event in your system. Try and think about using Node.js in a serverless way. It'll open your eyes up to what you can do. This is probably one of the easier ones. Migrate your build and deploy scripts to Node.js and TypeScript. Most people have these in like YAML files or bash scripts. We do, and most of ours are still in that, but we're moving to pure TypeScript. So this is something that's pretty low-hanging fruit. You could do that tomorrow. Automate your architecture, similar thing I was just saying. If you're not using TypeScript already as well, it's very simple to actually get started. You just rename all your files to .ts and add TypeScript to your Webpack, and you should be able to go. And yeah, that's it. And you can find me on stuff. I think that's, there we go. Thank you, everyone. Come grab me if you want a question. We should eat.
Okay, our second speaker is going to be Hayley, who is also from Agile, talking about translating a reactor.
I haven't talked yet. This is yes. Hello, friends and foes and enemies. Yeah. So this is okay. Yeah, my name's Hayley Tom. I work at Easy Agile. I moved to Wollongong about 6 months ago, I think, just yeah, when I started here. And I like the community. This is only my second thing that I've been to. And it's pretty cool so far. So yeah, that's all the intro to me that you need, I think. Today I'm going to be talking about translating a React app. So this isn't going to be too in-depth. This is more just like a an introduction to like the whole concept of like how do you translate an app? Like how do you internationalize something? So yeah, cool. So what is internationalization to begin with? It's not just language. It's anything. It's currency. It's date formatting. It's like right to left text support. It can be like icons, logos. Like in some cultures you might not want to use icons and stuff. But for our purposes, today it's language. Don't ask me questions about currency. It's language. So it's yeah. Okay. So for our thing today, what we're going to do is start with a React app that just has like how you would usually see a React app. It's just like JSX or TSX or whatever. You've got text in there, just hard coded, and we're going to pull all that out, rip it out. We're going to dump all that text into a JSON file, and then we're going to use a library, a client-side React library, to just basically pull it back from the JSON file and render it on the page where the English text was before. And then we're going to integrate that with a service that will actually do the translations for us and translate it. Grab that English JSON file, translate it into German or French or Swahili. Everyone uses Swahili. And yeah, and it'll be automated, so it'll integrate with Git, Hub, or Bitbucket. Everyone uses Bitbucket. I don't know why you laughed. Bitbucket's really good. So there's lots of different libraries you can use on the client side, and there's lots of different services out there that you can use to actually get your stuff translated. But this is like a lightning talk, so I'm not going to spend ages like comparing everything. Today we're going to use React INTL, which stands for internationalization, I'm guessing, and we're going to use Transifex as the translation service. So we're going to use React INTL to grab those English strings out of the JSON, render it on the page. We're going to use Transifex to send that JSON up there. It's going to run those English strings through machine translation, and it's going to give it back to us. We're going to integrate that with GitHub. So this is what we would have before. So a simple little React app. That's what it renders on the page. And this is what you would have afterwards. So just a quick breakdown. So we've wrapped our entire application in this provider. We've set a locale. We've passed it an object that has, it's just a key pair object. So the key is like the ID of the message. When you're actually coding throughout the development process, you're never going to type in things like this. You're always going to use these keys that you've set up in this JSON blob, JSON store. And yeah. And we're going to use this component here. So these both come from the React INTL library. We're going to use this component. We're going to pass it this ID that matches this. Okay. So the first step to actually getting this, so okay, just to backtrack. So this is a really basic version of like this. It by itself isn't very useful. This is just like we've done nothing. Like it's rendering the same result. But we want to get this integrated into our workflow in a way so that we can grab this and get it translated into other languages. So what we're going to do, because we're using Transifex, it uses this particular format, But most services use something like this. They expect like a huge JSON object that has keys and some sort of nested little object in here, because this can have other things in it too. This can have like comments, because those comments go to the person who's actually going to translate it later on. Or developer comments like, you know, please don't change the number 1 to the word 1 or whatever. You can do things like that. But for transifex, they want a key with string and this thing here. So since we've moved it to this JSON file, we're going to have to change our code from what we had before to have all this boilerplate. And this is kind of the sucky thing about React INTL. I think other libraries kind of do things a bit differently, but we've had to build in this essentially. This function grabs this JSON file and translates it, transforms it into a format like this, which React INTL can digest. And then we've got the exact same thing down here. As before, we pass this formatted message component, this ID, and it renders the same thing on the page. So now that we've got that, we can start getting the integration going with transifex. All right, so a basic, I'm not going to go into all the weeds of how you configure this and everything, because it can be a bit fiddly to get set up, but they have pretty good documentation if you wanted to, like, if you were interested in this particular service. There's others out there, but the basic gist of it is that, so you tell transifex, hey, the main branch of this particular repository for my GitHub repo, the main branch is like the branch I want you to watch. Any new translations that go into the English JSON file for this project, I want you to automatically machine translate those for me, please. And then open up a pull request with your bot, because like we've got that GitHub integration going. Your bot, please open up a pull request to that same repo with like the German translations or the Swahili translations or whatever. And then, yeah, that's kind of it. And this step, like once you get the boilerplate of this done, it's actually really easy. Like, it's so simple. I was really surprised. So this is kind of what the transifex dashboard looks like. I've set up this integration with our repository. This is just when I was mucking around with it, I just happened to use this project, these Agiles. I've linked it to that repo. I've told it that's the branch I want you to watch. And that'll just continuously watch that branch. The next time I make a commit to main that has any new English strings, or I've edited one or something, the bot's going to come along and do this. It's actually gone, oh, hey, this has changed. So here's the new translations. This is the file that we're going to update for you. And this is just machine translation, but you can set it up to be like a human will come along and do this, and then a pull request will happen or whatever. It's quite flexible. But for me, the ideal workflow would be like, I as a developer, I'm writing stuff, I'm coding in English because that's what I speak. I'm pushing stuff, and then this bot's like machine translating, so it's kind of crappy translations, but like it's something. And then later a human can come in and just like fix it up. And transifex does all that for you. And then, yeah, later on you can see in the dashboard, like these are all my languages. This is the percentage of the translation percentage for all of those languages. You can set it up to be like, oh, hey, like it's 100% machine translated, but only 50% human translated or whatever. And yeah, it's kind of it. And I promise I don't work for transifex. I work for Easy Agile. I'm not advertising for anybody. That's it. That is it.
And it's kind of redundant me saying their name where they work when the first thing they do is say their name and where they work. I'm just going to say this guy is going to talk.
Okay. Well, I'm not going to tell you who I am. I'm Sam. I work for Tibra. Tibra's closest office to here is based in Austin, Mia. We're a financial trading company. I think that's enough of an intro. So I'm going to be talking about WebAssembly. So my two main goals with this talk that I'd love for you guys to take away. If you don't know what it is, hopefully you'll know what it is by the end. And you'll know whether or not your company might actually want to use it. And the answer will probably be no, but we'll see. We'll see. Okay, that's the logo. That's enough of that slide. Okay, so unfortunately, WebAssembly, the name's not great. It's not just for the web, and it's not really assembly. So it's a 0 for 2. So if we think about the word assembly, so a few of us in this room might know what assembly code is. It's kind of like that very last step before you're actually machine code, before it's actually some binary that's going into the processor. And so it is your compilation target. So you don't code WebAssembly. You write a language like Rust or maybe Go or C or C++, and you can then transpile it into WebAssembly. So it's also shortened to WASM. So if I call it WASM in the slides, that's what that's referring to as well. So your browser already supports it. So the browsers, I think one of the main things maybe to consider is it's an instruction set. So an instruction set are the things that a machine can do. But there is no such thing as a WebAssembly machine, really. It's a virtual machine. And so you define a bunch of things that this virtual machine can do, and then your browser runs this virtual machine. And so in WebAssembly land, you might have an instruction that says add these two numbers together. But your great new laptop might actually be able to add a whole bunch of numbers together all at once. And so it's up to your browser to then compile that into the native instruction set of your processor, and it can do optimizations during that step. Every browser that you can kind of think of already supports this, so you can use it already. So I think it was quite a few people have described Google as a bit of an unstoppable force, but when these guys all team up together, that is quite the unstoppable force. And so all these companies are involved. This has a lot of momentum behind it. And this is all an open standard as well. So all these companies are working together, contributing to an open standard, which is fantastic. This is already being used. So any engineers might have heard of AutoCAD. It's an old code base. And you can actually just take your existing code base and compile it into WebAssembly and then run it in the browser. Unity runs in the browser, thanks to WebAssembly. Blazor, any C# people in the room? Good. If you really wanted to, you could run Redis, VLC. BBC's iPlayer has quite a lot of enhancements that are all based, quite focused on WebAssembly. Google Earth, and I just want to point out this one. It's not just good actors who are using WebAssembly. If your laptop ever gets really hot, if you're on a dodgy website, it might be mining crypto, and that will probably be WebAssembly. But you'll be rich. So those in the back might not be able to read this, but 3 key points why I think WebAssembly is great. It's fast. It is fast to get into your browser. There's a special trick that you can even do. You can actually instantiate it as it's still downloading. So you can already be interpreting it into your native machine code before the file's even downloaded. Every browser apart from Safari, I think, can do that quite easily. Safari, you have to do a multi-step. It's safe. It's all in a box. It can't hurt your machine. I talked about compiling to like the instruction set of a virtual machine. If there is no definition of accessing something on the file system, the machine can't do it. An extension to WebAssembly is called WASI, WebAssembly System Interface. And if you want to run your WebAssembly outside of the browser, as I discussed in the first slide, it's not really web, it's quite a few things now. If you want to run outside of the browser, say like a module in Node.js or something like that, you might actually want to have some form of interface to your system. And so I'm not going to talk about WASI anymore in this talk, but that's a search term you can look for. It's open. It's open in terms of it compiles to something that you can convert back to text. Anyone who's a fan of Lisp would love this format, but I don't think anyone is. And it's also open in, you don't need any licensing fees to use it. It's an open standard. It's already built into your browser, so you can already be using it. So this is a diagram by, I've covered up the name, and I can't see my mouse cursor, so my apologies. I think it's Lynn Clark. So diagram by Lynn Clark. So JavaScript is doing quite a lot. And one of the reasons for the speed of WASM is because it doesn't need to do as much. So it's a very compressed format that's ready to go into your browser, and it's not much of a step away from something that'll actually run on your CPU. There's a lot of interpretation, garbage collection, and a whole heap of other things that JavaScript needs to be doing. And so simply because WASM does less, it runs faster. There is no official scale there. I think time for a demo. So if anyone wants to, you can go to a URL, darkredaudio.com. Don't open it in Safari because it's not going to work, but pretty much anything else will actually hopefully work. Hey, my phone's getting hot. You mind? Not tonight. Does anyone know how to zoom a browser when the zoom doesn't work? Pardon? Click the little green round button. Okay, I think that'll do for now. I'm going to refresh this page. So what I have here is a very straightforward gravity simulation with about 50 points. They have random size, random velocity, random position. And I have written the exact same code as closely as I can, both in Rust and in JavaScript. And then the Rust has been transpiled over to a WebAssembly module and then instantiated and run. And just for fun as well, this is all handled by a service worker. So I think it should also work offline if you turn your phone to airplane mode and refresh. But the point of the talk is the speed difference between the two. So this is real-time profiling. And so as you can see, the WebAssembly, not only does it run faster, but it's also quite tight. So this is 10 milliseconds. And just to have a little bit of an idea of what's going on here, although most of them have kind of disappeared off the screen, we have 50 points. Every one interacts with every other one, which means we have 2,500 gravitational pulls that need to be calculated per frame. 60 frames wasn't stressing it enough, so we're actually running at 1,000 frames a second and then rendering every 33rd. So it's running at 60, calculating at 1,000. And that's 10 milliseconds per frame. And so we're hardly in the 1 millisecond kind of time zone, and we're running both at once. And it's a 2015 MacBook Pro. So WebAssembly is fast. JavaScript's also fast. It takes quite a bit to stress both of them, but the main point is not only is the WebAssembly finishing faster, it's also finishing faster more consistently. So if you're doing anything that actually needs to be done before the frame runs, the frame renders on the screen, you can see this long tail of the JavaScript. So especially for anything that requires rendering, you can actually get much better results in WebAssembly. And if you're using Rust, you've got support for multi-threading. To try and keep it as fair as possible, I tried to restrict them both to one core. So very simply, you can have a look at the code later, but it's just a bit of Rust and then the same thing written in JavaScript. So back to the slides if I can find them. So the people who are going to benefit from WebAssembly most, if you have an existing application that you want to get in front of more customers, and WebAssembly might be a great way for you to transpile it into something that could be injected into a web page. Like people have run games in WebAssembly, you're approaching native performance. So if you've got an app written in C, C++, or there's a huge number of languages being supported, it's a little bit trickier getting languages that need a garbage collector running into WebAssembly because you have to compile in your garbage collector as well. Also, if you want to get every last scrap of performance out of your browser. So we saw in this very straightforward demo, we are getting better performance running it in WebAssembly. And I had a look at the profiling, and it's just because it's not doing any garbage collection. So it doesn't need to allocate any memory, doesn't need to deallocate any memory as it runs. It's all just CPU bound. And so you don't need to rewrite your app in WebAssembly. You could pick one module that's like hot. Does anyone use the term hot when they're talking about kind of like profiling? It's like the one bit of code that just gets run again and again and again. If you identify a part of a module that is very hot and it's dragging down your application, you could actually rewrite it in WebAssembly and you might get some performance increases. I think that's about it. Any questions?
Yeah, thanks, Sam. Really interesting.
Thanks.
Does your work at Tibra find WebAssembly interesting?
So this talk I've thrown together in the past week or so. I hadn't really used WebAssembly at all up until this point. We don't use it at Tibra at all, but whenever you've got a solution, you can go search for a problem. And so there are a couple of applications that might be well suited to taking a very chunky bit of C++ and actually putting it into the browser so we can actually get a better interface for the traders. So it's one example.
Yeah. So if I had like an app written in C++ Win32 API showing a window and that sort of stuff, you bring that across into WebAssembly, does someone need to implement it separately like the Win32 API in WebAssembly? I assume it doesn't just magically.
Yes, and I've forgotten the name of the project, but someone has done an amazing job actually. Yeah. And that was written quite a long time ago. WebAssembly has evolved quite a bit since then. And yeah, so it is still a wonderful tool. It is quite heavy if you're importing a huge amount of stuff into it. But yes, you can do that. So AutoCAD, as I mentioned, that's a 30-year-old code base or something like that. And without many major modifications at all, they were able to compile to the WASM target and then just present it as a fully featured application in the web browser. Anything else?
Might be outside of the scope, but like I'm pretty new to profiling. I don't know how common those as everyone else to be doing, like in sort of web architectures and stuff. Do you know of ways, or do you have ways that you do your profiling?
Yeah, absolutely. So it depends on what really you're going for. So if you define well what your performance goals are, so if you want a smooth 60 frame per second app, then you can kind of imagine you've got your 33 milliseconds, is it? 16? Yeah, cheers. Yeah. So you have a limited amount of time. And so you know you need to get under that guideline. And so most browsers have built in some form of profiling. Just a tip for the demo. I can get back to it. So if you guys go on your phone, you might find that your little histogram is not nearly that kind of resolution. As a security concern, if you can measure time too accurately, you start letting in the class of problems like Spectre and stuff like that. And so by default, most browsers will round any timings to the nearest millisecond to make it much harder to do that. But throwing a flag in Firefox, you can get it to microseconds. So turn that one on if you're going to do some profiling. And so I think it's performance.now. We'll just give you a high accurate timestamp that is better for profiling than like date now or something like that, or whatever the JavaScripting is.
Sam, thanks, mate. It's been a great talk. Just wanted to know what the development experience was like in debugging in the browser.
That's a really good question as well. So for me, I wrote a bit of Rust, super easy, and my entire to recompile everything and build everything and inject it into an Nginx server ready to go. Just takes a second to stop the Docker container. But that's about it. So there is a lovely little package that kind of wraps up the process of taking that Rust code into WebAssembly and then wraps it as a Webpack. So it's kind of like an interaction between writing in Rust. And so if you're already using Webpack, I think that'd be a great way to go. But there are also great tools where if you really want to, there's a text implementation of WASM. It's horrific to write, but if you really wanted to, you can then just convert it straight to WASM. Then the same library on GitHub, you can take your WASM code back to text. So you can actually have a look at the instruction set in a somewhat human readable format. So you know exactly what's being included there. And the WebAssembly package that I mentioned, it does actually throw a bunch of wrappers around some of the things. So you do actually get some helpful error messages if something can't instantiate correctly or something like that. But it really is writing assembly code. And so if you compile out, like with a flag in Rust to say, I don't want anything to do with panics handled, your code will just die quietly. And so you can kind of compile in whatever level of developer assistance you'd like. And that's based on the programming language you decide to use. But quite easy. I'll see if I can find the code. So this line here, so a one-liner to import, to not only get it from the server, to instantiate it and have an instance of it as a module, init. So very easy to start using it. And then anywhere that PW is used, so I'm seeing a gravitational constant, I'm just calling out to the module. So the module actually has it's a stack machine, so it has memory. And so then I'm just calling a function that just sets that part of the memory that holds the gravitational constant. Yeah, so very easy to use.
So do you have to do all development through a browser, or can you do Rust development outside in different, more be a dev loop and then just try it in the browser later?
Yeah, absolutely. So for the Rust code, I'm putting on kind of tags on top of functions. So if you're using Webpack method, wasm bind gen, it just says this is something that I'm going to want exposed, and I've also marked it as a public function. So wasm bind gen, and that's enough to get all that helpful wrapper and mark it as something that will be exported and visible. And if I just don't throw that pub on there, then it's not accessible. It's just an internal function. And then this is just normal Rust code. I can compile it to something that'll run on my machine, and I can write unit tests in the typical Rust fashion. You can kind of just embed them in line, and so it can actually run them at compile time. Rust isn't too opinionated. You can do a bunch of different forms of testing. But yeah, you can stay purely in Rust, and then you can just have multiple compilation targets. So you can say, I want to compile a local binary, I want to compile a WASM binary, whatever. So really good for developers as well. I think anything that Mozilla really gets behind, you end up with really good documentation and developer experience. So
Is this up on GitHub to check out?
oh, if you want it, yeah, I'll send it to you. Yeah.
Awesome. Thanks.
Yeah, like with Webpack, how you can, minify your JavaScript and then have source mapping and debug your original JavaScript. Can you debug your Rust code and step through that while it's running in the browser?
Not really, because I really hope that something like that does come out. That like if that's the style of debugging you're used to, I'm sure that'd be really helpful. But I haven't actually seen a good implementation of that yet. At the moment, I'm very good at just like the print statements kind of form of debugging. And yeah, as Dave alluded to, like you can just run your Rust code as you normally would, and so you can use whatever form of debugging would work there. But you can, there's quite easy interaction. So from the Rust code, I can tell it that a JavaScript function exists and then it's allowed to call it. So like I could call an alert on a page or something straight out of Rust, which is then actually coming out of WebAssembly. And then also from JavaScript, I can call something into WebAssembly as well. And if you're really desperate, you can actually just open up an array of the actual stack memory space, and you have the raw binary of what it's doing. So in that demo, those stars were actually instantiated exactly the same, but tiny little rounding errors, chaotic system very quickly turn into different patterns appearing on both. So
So that you have like the same canvas or whatever it is, instantiated twice, once with JavaScript and once with Rust.
Yep.
That's the interface of the browser. The Rust is calling a function to tell it what to do, and then JavaScript's doing that. So Rust isn't responsible for the UI, it's just the machine behind it.
Yes, so Rust is running the physics simulation for the WebAssembly side, and JavaScript 1 was just running behind the scenes in the browser. And then they are almost line for line the exact same code. And then a very final step is the render function for the WebAssembly side just requests what the current state is of each of the stars. Yeah. So more and more browser interactivity is being built into WebAssembly, but it's already very rich in JavaScript and it's easy to interface. I guess something that might be helpful would be logging directly from your WebAssembly, just straight into your console log. So you can do that as well. Yeah. Also, Tibra's hiring.
Cool. Okay, so that was our 3 speakers. Big respect for everyone who spoke. I know how much time and effort goes into preparing for that. So thank you. If you want to present, it has 1 line of code in it, you can present here. Just get in contact with me or Jared on Slack, or go to Siligong.dev. There's an email there you can use. Just get in contact. If you're presenting for the first time and you're a bit afraid, you can also pair present with someone who might be more experienced. So don't let that stop you, just talk to one of us. Thank you to our sponsors, Devika and Easy Agile, for making this happen. Also, can you put your hand up if this is your first time at Siligong.js? 1, 2, 3, 4. Cool. How did you hear about us?
We're in.
How did you?
Work at a seller. Yeah.
Work at a seller. Who else? You don't count. Work.
Yeah, I learned the Slack when I moved back to Australia, and then I sit next to Sam.
Okay. Behind.
So I was actually searching for companies here, and I don't remember exactly how I came into the group of Slack, but I think I went into the Easy Agile website, and then in some part they told about the Slack group, and I said, okay, I'm going to join that, and yeah, so I've been a member for like a few months now.
Okay.
Quiet one, because I'm studying, but I saw like this meeting coming up, and it said it's time for just get myself out there, so it's great. Thank you.
Cool.
I've been on the Slack channel for quite a while over a year, but everything shut down under COVID, and I think I first heard about got on the Slack channel through possibly an advertising meetup or something like that. I think I was looking for what was the local version. I used to live in Sydney, so I was looking for what was local down here, and that's how I found the Slack channel.
Cool. Thank God you don't. All right, cool. Like Sam said, Devika's hiring. Easy Agile is hiring.
I said Tibra's hiring.
Tibra's hiring.
Devika's hiring.
Devika's hiring?
We're always hiring.
Okay, always hiring. Cool. Is there anyone else from another? Nick?
Oh, sorry, I was just going to ask, when's the next Siligong.dev meetup?
6 weeks from now.
Okay, 8 weeks. 8 weeks from now.
Okay.
What?
That's what I put it on the channel. It's changed it to 6 if you want. I think 6 might be a bit aggressive.
8 weeks. Okay. 8 weeks from now. It will be on the website and we'll put it on Slack as well. Is there any other companies here that are hiring that want to say you're hiring?
Yeah, probably
That is Glenn from Acela. They're hiring. Cool. If you have any feedback, bad feedback goes to Jared, good feedback comes to me. Again, just ping us on Slack or email. Anything you want to see or don't want to see, just let us know. We're trying to adapt this, grow this as much as possible. I think that is it. Devika people, does everyone get booted like right away, or can they stay, or they can stay? Cool, you can stay. Well, no. Cool. All right, thank you, and thanks again to the speakers.